This is JKM again for part 2. I've introduced the game already, and now we move on to the Lezonti bot matrix. This may seem complicated, but it's not if you know simple or basic algebra. Remember these factors from the previous part where I introduced the game. I'll now show you how to use them practically when you're drawing your own target board. And remember that this part is for exactness or advanced measurement plotting of the target board. If you look at the theory here, it reiterates what I've said in the first part. It says for a rectangular area of 55 centimeters multiplied by 49 centimeters, the thrower is obliged to take not less than 20 steps backwards from the target board. And note that in this part, we are going to deal with the horizontal distance measurements. Let's take as examples footstep distances of 40, 500, and 5. But let's first analyze what we are working with here. And as you can see, in all three cases, the number 40 is a universal constant or an indisputable number, special constant. The first step of this calculation is we multiply the footsteps, the number of footsteps, by 2, and you get your heated or height numbers. Also have to be factored by the constant 40 in order to cam the mechanism or ability to calculate what we need. 40 then is now acting as a variable expanded, and here you start to see something blossoming. Note that everything on the right hand side of these expressions is in centimeters. And also note that we are taking into account 1/2. So we are going to use 1/2 of the board. We are going to take the 5 footsteps object as we are trying to make it easier to try to find what we are looking for. So for 5 footsteps, how much horizontal distance does our board have to become? To start, we use the Lezonti theory. The Lezonti theory to reference what we are relatively conducing. And as you can see here, everything is up to standard. We get our unknown horizontal distance. This is our workout and can also be transformed into formula or object form. And finally, you can use this special formula to determine each horizontal distance of the 4 categories of the target board. So this was just for 1/2 of the board. And for the full board, you can divide by 2 instead of 4. And another thing to note is vertical distance as required by 5 footsteps is between 10 centimeters and 14 centimeters. And so guessing work is kind of permissible, and that's one of the beauties of this game. And for this next part, I'll show you how to find out how many footsteps to take when you've already drawn your target board. And this is also easy and quick. Let's use the familiar or pre-existing board with vertical distance of 100 centimeters and horizontal distance 94 centimeters. And so how many footsteps for our model target board? We use our third expression, horizontal distance equals to height vector times board vectors times standard horizontal distance, all divided by our special constant as shown here. 94 horizontal distance, height vector, board vectors, standard horizontal distance from our Lezonti theory, all divided by 40, our special constant. Our board vectors naturally cancel our special constant, and so we are left with this final solution. Height vector is 94 divided by 49. Not a big height vector, still manageable. And moving on, we are going to do 2 tests to see if we've done the calculation right. The first test is to see if our value makes sense. And so, yes, it makes sense. And this test is to see if the values of the